So now let's try one more example here. Y equals sine 6x. We want to graph y equals sine 6x. Similar to the previous example. And like in example 5, we're going to try to work with this in a more general way, where we apply this idea of finding the period first before we start plugging in values. In the previous video, we saw that if we want to find the period of y equals sine bx, we could either set up an inequality with 0 and 2 pi at each end and bx in the middle and isolate x, or we can just use the formula period equals 2 pi over b. In fact, this period is exactly what you get from that inequality. So I'm just going to go ahead and use the formula 2 pi over b. So here the problem is that we want to graph y equals sine of 6x. And so our b value is 6. So the period is going to be 2 pi over b, which is 2 pi over 6. And that reduces to pi over 3. So we have this, to me, I have this picture of a piece of the x-axis from 0 to pi over 3 is going to be, one period of the function. But now, just knowing the endpoints of a period aren't enough, because if we go back to our basic graphs of sine and cosine, we really want to separate a period into 1, 2, 3, 4 pieces, right? So that we know so that we can identify the max point and the min point on the graph, the high point and the low point. We know we go 0, 1, 0, negative 1, 0 with a sine function. So instead of finding quadrantal angle values here, we're going to just have to take this interval from 0 to 3 pi, and we need to divide this interval into 4 equal pieces. So I'm actually going to take pi over 3, which is the period, I want to take the period and divide by 4. So I'm going to take pi over 3 and divide by 4, which is pi over 3 times a fourth, or pi over 12. So this pi over 12 is going to be a useful x value. I'm going to take this interval 0. I'm going to mark off pieces that are each pi over 12 in length. So I start at 0, add pi over 12. At another pi over 12, I get 2 pi over 12. At another pi over 12, I get 3 pi over 12. At another pi over 12, I get 4 pi over 12. Now, some of these fractions reduce. For instance, 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is just pi over 3, and notice that's the period. So we took that period interval and sliced it into 4 pieces. There are actually 5 important points if we count 0, 2. So just here's one period cut into pieces. Now, you won't have to plug in once you get used to it, but I'm going to use these values in a table just this one time, because I want to make sure you see what we've found here. So those values are 0, pi over 12, 2 pi over 12 was pi over 6, 3 pi over 12, pi over 4, 4 pi over 12 is pi over 3. These new values work kind of like the quadrantal angle values. When I plug into the function sine of 6 times 0 is sine of 0, which is 0. So again, you don't have to write this down really. 6 times pi over 12 is sine of, that's going to reduce to sine of pi over 2, which is 1. Sine of 6 times pi over 6 is just sine of pi, which is 0. Sine of 6 times pi over 4 is the same as sine of 3 pi over 2, which is negative 1, and sine of 6 times pi over 3 is sine of 2 pi, when I reduce that, which is sine of 0. So these values that we found by taking the period, dividing into 4, give us the values that are going to give the number, are going to tell us where the zeros, the high points, and the low points are on that graph. Now this is an example where we got to set up we got to label the axis now, and to me the key value here is pi over 12. So I'm going to go pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, that's just pi over 2, 7, 8, 9, 10, 11, 12 pi over 12 is just pi. But now I labeled more than I really wanted to right off the bat, because I wanted 1 pi over 12, 2 pi over 12 is pi over 6. I'm just going to put pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. And the reason I want that to stand out is from 0 to pi over 3 is 1 period for the function we want. Now I got to label a 1 and a negative 1 on my vertical axis. So here's x, here's y. And I know from the values we have, I go 0 up to 1, down to 0, down to negative 1, back to 0. So 1 period is going to look like this. Okay. And from, that pattern is just going to continue where 1, 2, 3, 4, 5 pi over 12, 6 pi over 12, 7 pi over 12, 8 pi over 12. Notice that that's just 2 pi over 3. That's going to be another period, right? I'm going to go up, down, negative 1, back to 0. And this pattern just repeats itself over and over again. And there I am at pi. And of course I can go in a negative direction, negative pi over 12, negative pi over 6. Okay. So 1 period is pi over 3 for this function, and the amplitude is still just 1. Amplitude is 1. So the 6 factor doesn't affect the amplitude at all. Now I wanted to, let's see, pi 1, 2, 3, 4, 5, 6. This is going to be 12, 13, 14, 15, 16, 17, 18. This is 18 pi over 12, which is 3 pi over 2. I just want to get out to 3 pi over 2. So I'm going to just continue I know my wave pattern for this function is just going to repeat over and over again, right? Period over and over. So I'm drawing many periods of this graph because you won't normally have to draw this much. So this is 1, 2, 3, 4, 5, 6. This is negative 6 pi over 12, or negative pi over 2. And I just wanted some of these, a lot of this graph drawn, because here's negative pi over 2, here's pi over 2, here's pi, here's 3 pi over 2. I want to add the regular sine graph to this picture just for comparison. So normally you don't have to do this. Normally I would just ask you to draw at least 2 full periods. So I have way more than 2 full periods here. The regular sine graph is going to be 1 at pi over 2, 0 at 0. So on this scale it's going to look sort of like so, come down to 0. At 3 pi over 2, that's where it's finally going to be negative 1 and turn around. And at negative pi over 2, the regular sine graph is negative 1. So there's y equals sine x superimposed on the graph of y equals sine 6x. And I just, again, I wanted you to see how we've compressed that period of sine x quite a bit here, so that the period of the y equals sine 6x is actually just pi over 3 units. We cut that into 4 pieces so that we could plot the important points to get one period drawn carefully. So we're going to set up a step-by-step process in the next video now.